For which of the following curves is dy dx positive for all values of x? Alright lads, you listening? Remember when you're playing the game Super Mario, when you go left to right, that's a positive slope. Okay? Sorry. When you run left to right, that's a positive slope. So you end up running up the hill, that's positive. If you go down the hill, it's negative. So, in the first equation, what happens? Negative slope followed by a positive slope. What about this one here? No matter what, it's positive. And the last one? He's negative because he's always running downhill, right? That's easy enough, isn't it? So everybody say that the answer is part 2. The first derivative is positive because the slope is always positive because you're always going upwards. Alright? Going left to right. Now, what about this one? Which one is it always negative in? Huh? Negative for all values. I think it's negative for all values here. Curves, plural. So I think it's part 1 and part 3. Because this one here, you go up and down again. And then this one, you're always going downwards. Is that alright? Cool. Slope function of a given curve. Alright. If you guys remember what we did the other day was, what I showed you was the following. If you have a cubic equation, okay, and for argument's sake, I say this the max and the min are here, okay? So, would everybody agree that, just give me a sec. Would everybody agree if you drew a cubic equation of some variety, just plus a load of stuff, alright? Doesn't matter what it is. And let's say for argument's sake, I say this is at the point 17 is the max and the min is 3 minus 5. Everybody cool with that? What happens when you draw the first derivative? If the original graph is a cubic function, what's the derivative going to be? Some version of a quadratic. And what shape is a quadratic? U-shaped. And where will it hit the axis? Always hits the axis directly underneath the what? Underneath the turning points. Okay? Now, if you don't believe me, I'll just get on to GeoGebra in a second, okay? But here's what I want. Here's what I'd like you to do, alright? So, if we pick a cubic function, so I'll just go back and pick a good cubic function for us.